Welcome to our last tutorial on this chapter, that is force and momentum. So we have covered all the examples what we have done till now, and we have completed. So in the last lectures we have solved one problem which was based on Newton laws. We have one homework here which is to be done. Then we have learned the concepts of linear momentum. We know what is meant by momentum. Momentum is mass into velocity. But here we have given the definition for total linear momentum. It's just an addition of momentums. We call it as a total linear momentum. And then we say we have determined the law of conservation of linear momentum. So what is meant by the law of conservation of linear momentum? It means that if the net external force acting on the system is zero, then it's a total linear momentum is conserved. Okay, so we have this from our day-to-day life. So we have solved one problem based on that, and we have got the which was required. So now we have started with impulse. Impulse means a large amount of force is being applied on a body for a fraction of time, and the formula for the impulse is J is equals to F into T. The unit is N into S for impulse. We have the expression for impulse J is equals to F into T, which is nothing but change in. So now we are going to start our new topic for our today's session, and that is the last topic for this chapter. So with this we will be completing the second chapter of our syllabus, that is the force and momentum. So let's begin with our topic. So our topic is motion with variable mass. Okay, so now there was an example. This one is a conveyor belt. Anything if I'll keep, it will go along this. So this belt moves along this continuously in a circular path. Okay, so that we are going to use it here. Now let's take this thing. So as per the Newton's second law, okay, if I vary the mass of a system with time, so my F is equals to dp by dt. So what is P? P means momentum. Momentum is mass into velocity. So d dv mv by dt is equals to, so if I am using a derivative formula, that is d by dx of uv, it will give me u dv by dx plus v into du by dx. So same way I have written m dv by dt plus v dm by dt. Okay, now as we said, under the special cases the v is constant. V का जो वैल्यू है वो constant है. अगर v constant है तो F is equals to v dm upon dt. That's it. That is motion with variable mass. ठीक है, इतना क्लियर है. अभी हम लोग एक एग्जांपल सॉल्व करते हैं. ये वाला जो अभी मैंने यहाँ पे नीचे एक जो डायग्राम फोटो बताया था, जिसमें वो था कन्वेयर बेल्ट से जो बॉक्स है वो एक जगह से दूसरी जगह पे जाता है. तो सेम वे ये भी एक कन्वेयर बेल्ट है. ठीक है, ये नीचे से इसका व्हील है. सो ये सैंड ऊपर से नीचे गिर रहा है. So sand is being falling on this conveyor belt. ठीक है, so sand falls on a conveyor belt B at the constant rate of 0.2 kg per second. Now find the force required to maintain a constant velocity. अभी हमने कि force कितना चाहिए जिससे इसमें constant velocity होगा of 10 into 10 meter per second of the belt. ठीक है, तो अभी हमारा ये जो कांस्टेंट रेट जो है वो कितना दिया हुआ है, दैट इज 0.2 kg per second. The value is being given, हमें फोर्स निकालना है. So force is equals to velocity into dm by dt. So velocity, ये देखो ये फॉर्मूला यूज कर रहे हैं v और dm by dt. So हमें कितना फोर्स अप्लाई करना पड़ रहा है, तो डायरेक्शन ऑफ फोर्स एंड द वैल्यू ऑफ दैट फोर्स. So we have to maintain a constant velocity of 10 meter per second of the bend. So उस फोर्स का वैल्यू कितना आता है, दैट comes out to be 2 Newton. ओके अभी वो एक एग्जाम्पल था. अभी ये और एक एग्जाम्पल है. वी आर हैविंग अ मोशन विथ वेरिएबल मास. दिस इज अनदर एग्जाम्पल. सो दैट वाज वन एग्जाम्पल, एंड हियर इन दिस part what we will see here, it's a rocket which is going in a forward direction. So the weight of the rocket is in the downward direction, thrust is in the upward direction, and the exhaust gas motion is in the downward direction. There is no difference between this diagram. These are same only, but this is a colorful diagram, and the values to be measured in this concepts are being mentioned. So that's the reason I have just taken this diagram. Okay, so now here in this case, as I said, in a rocket a stream of gas produced. So here gas is produced, so that is of very high temperature and pressure, and it escapes at very high velocity through exhaust nozzle. So here we are having exhaust nozzle, so through which the gas is being expelled with a high velocity. So the rocket loses mass. rocket का जो mass जो होता है वो कम हो जाता है, and so that mass is dm by dt, and that is negative. So the main body of the rocket experiences a huge force in a direction opposite. तो mass छोड़ रहा नीचे वाले direction से छोड़ रहा है. So what will happen? So it will experience a huge force, and that is a downward. So the direction of the force is opposite to that of exhaust, causing it to move. तो ये जो फोर्स है, जो हमें जो ह्यूज फोर्स जो बोल रही वो डाउनवर्ड में है, और ये अपवर्ड में इट्स मूविंग इन द फॉरवर्ड डायरेक्शन. सो इट्स अ सिंप्लीफाइड वे ऑफ डीलिंग विद द मोशन ऑफ रॉकेट. So we shall next analyze the motion of rocket. So we will just do the analysis. So we have two examples, one with the help of the conveyor belt and the other one with the help of rocket. So we have learned the motion with variable. Now let's see the motion of rocket. Okay, so now here same thing, the diagrams which I have used it before. So those diagrams only will be taking, actually that concepts only will be taking, but just I have separated this into some different blocks so that it will be easy to understand what exactly is being going on. Okay, so here in this case the mass of the total mass of the rocket is m, and at what time t, and it moves with the velocity v and ejects, मतलब वो एक्सपेल कर देता है मास जो छोड़ देता है, तो उस मास की वैल्यू क्या है, डेल्टा एम एट अ टाइम डेल्टा टी. ठीक है, द सिचुएशन. ओके, नाउ हियर टाइम टी मतलब द टोटल इनिशियल मोमेंटम ऑफ द सिस्टम इज एम इंटू वी. थोड़े टाइम के बाद में तो उसका जो वेलोसिटी होगा वो इंक्रीज होगा v प्लस डेल्टा वी. सो एज अ रिजल्ट वो आगे जाता है रॉकेट, बट स्टिल हियर it will lose some mass. So that is original mass minus some expelled mass. So that is m minus delta v. Okay, and this delta m is that expelled mass. It is having some velocity, and that is u. So as a result, so this is the initial velocity of a system and the total final velocity of the system. So it comes out to be again mass into velocity. So what is mass into velocity? It comes out to be m minus delta m into v plus delta v plus delta m into u. Okay, now what we'll do, we'll apply the concepts of our total final momentum of a system. So now here in this part, the now if we take the vertically upward direction as positive. So this, if we upward direction as positive, the impulse is minus mg delta t and is equal to change in linear momentum. So as a result, the impulse is equals to minus mg delta t is equals to m minus delta m into v plus delta v plus delta m into u minus mv. So we'll open the bracket. So this and this, the terms get cancelled out, and we'll just write down the last term, that is m into delta v plus mv delta m into u minus v minus delta v. ठीक है. Now we'll use the equation which we have learned in our chapter number 1, that is 1.35, to simplify the above expressions. तो अभी अब ऊपर का जो expression है जिसे हम लोग इसे सॉल्व करेंगे. सो दैट विल बी माइनस जी डेल्टा वी बाई डेल्टा टी, डेल्टा वी बाई डेल्टा टी, फिर ये m, सो 1/m. सो यहाँ का भी m निकल जाता है, एंड वी आर डिफ्रेंशिएटिंग विथ रिस्पेक्ट टू डेल्टा टी. सो यहाँ का सिर्फ माइनस जी रहता है, ये वाला डेल्टा v अपॉन डेल्टा टी होगा, प्लस दिस विल बिकम डेल्टा m अपॉन डेल्टा टी. एंड व्हाट अबाउट दिस टर्म? सो दिस टर्म, ये जो पूरा का पूरा टर्म है, उसे हम लोग ने रिप्लेस किया u real. इट इज द रिलेटिव वेलोसिटी ऑफ एग्जॉस्ट. एग्जॉस्ट का जो वेलोसिटी हो, जो बैकवर्ड डायरेक्शन में जो एक्सपेल्ड होता है, उसका वेलोसिटी. सो दिस इज द रिलेटिव वेलोसिटी ऑफ द एग्जॉस्ट विथ रिस्पेक्ट टू रॉकेट. तो हम लोग ने रेफरेंस किसका लिया है? रॉकेट का. ठीक है. नाउ एट डेल्टा टी टेंस टू 0, मतलब एक बार टाइम पे हमारा टाइम भी खत्म हो जाता है. सो इस वक्त ये इंटीग्रेट किया है, माइनस जी इज इक्वल्स टू डी वी बाई डी टी माइनस 1/m dm upon dt u relative velocity. Okay, the negative sign on the right hand side of this equation, it appears like minus g limit of delta t tends to 0 and delta m by delta t is equals to minus delta m by delta t, because m decreases with time. So what does this equation say? It says that we can apply equation 2.32 in numerical methods. We just replace dm by dt by its magnitude. Okay, now what we'll do, we'll integrate this equation. This whole equation, if we'll integrate, so integral 0 to t dv by dt into dt is equals to ये minus gt plus u real integral m naught to m dm by m. So what is m naught? M naught is the initial mass of rocket and m is its mass at time t. So now if v naught is the velocity, then we get, अभी जो हम लोग को वेलोसिटी चाहिए था उसका एक्सप्रेशन आ रहा है. सो वो क्या एक्सप्रेशन मिल रहा है हमें? v माइनस वी नॉट इज इक्वल्स टू यू रियल ln ऑफ m अपॉन m नॉट माइनस ऑफ gt. ठीक है. एक हम लोग प्रॉब्लम सॉल्व करते हैं इस बेसिस पे. ठीक है. द स्टेजेस ऑफ अ 2-stage रॉकेट. रॉकेट में 2 स्टेजेस होते हैं. ठीक है. सो 2-stage rocket, it has mass 100 kg and 10 kg and contain 800 kg and 9 kg of fuel. ठीक है, separately. तो ये fuel की values है. Now what is the final velocity that can be achieved with an exhaust velocity of 1.5 km per second relative to the rocket? Fine. So how much it will be? Final velocity we are going to calculate. So now first of all, in the previous case, whatever the expression which we have derived, same thing will continue, that v minus v naught is equals to u real ln of m upon m naught. Now what we'll do, we'll apply the unit vectors. So it is moving in the upward direction, so we'll apply some unit vector. So here in this case the unit vector is n crown. So v n crown minus V naught n crown, which is equals to minus U real n crown ln of m upon m naught. Now U real is equals to, that is relative velocity, is equals to minus of U real of n crown, which is the velocity, relative velocity of the exhaust pointing vertically downward. So V minus V naught is basically minus U real ln of m upon m naught. So now in this problem, if I substitute the value of this as 1.5 km per second, so what we will get, so our first stage velocity V naught is equals to 0. So m naught is equals to 800 plus 90 plus 100 plus 10 kg. So which is equals to 1000 kg. So here in this part, so again m is equals to 90 plus 10 plus 100 kg, which is equals to 200 kg, as the 800 kg fuel gets burnt in the first stage. So as a result, our previous expression we can write it as V is equals to minus 1.5 km per second ln of 200 upon 1000. So minus 1.5 km per second ln of 2 minus ln of 10. So here in this part, this will be 1.5 into 10 to power 1.6 km per second. So which is equals to 2.4 per seconds. Now again, if you will see that all the above initial value for the second stage, also note that at the beginning of the second stage there occurs another drop in mass to the extent of the mass of the first stage. So for the second stage, V naught is equals to 2.4 kilometers per second, then m naught is equals to 90 plus 10, which is equals to 1000, and m is equals to 10 k. So V is equals to 2.4 minus 1.5 ln of, this is just a mathematical part, that is 10 by 100 kilometers per seconds. So 2.4 into 1.5 into 2.3 kilometers per second. So it can be written as 5.85 kilometers per second, or it can be written as 5.8 kilometers per second. So you can write it like this, just with the decimals arranging and all. That's it. Thanks for watching.